This problem is 1.30. It says a crane is shown supported by two cables, cable BD right here and cable BE, and we have to figure out the forces in these cables, right? And there is a 50 kilonewton weight hanging right here. So since this is coming through this cable here, so in this cable the tension right here is going to be 50 kilonewtons there, okay? And in these two cables here there will be tension here and there will be tension there. So we can call this TBD and this one as TBE. Now we can isolate this AB bar here and draw the free body diagram. So in that free body diagram we are going to have this force, this force, this force right here, and a vertical force coming here from the support as a reaction on that joint right there. If you do the force balance on this, your force balance can be written in terms of vectors. So we'll do summation of all the forces equals to 0. Now going by the coordinate system, we have this 50 kilonewton force, which is 50 I cap because it's pointing in the x direction. This R right here is going in the y direction, so R j cap. And then we have these two forces, one is TBD and one is TBE. So all of these forces needs to be equals to 0. Now this TBD force and TBE force, since they are along these cables, we need to write these forces with the help of the vectors along those directions. So if you notice BD vector here, BD vector is basically how do we reach point D starting from point B. So for that we can see that we have to travel along x direction by 3 meter in the negative direction, so this becomes minus 3 I cap. This 4 meter right here vertically downwards, meaning minus 4 j cap, and we have to go backwards here by 2 meters, so minus 2 k cap. So now this is the vector, but if you are interested in finding out the unit vector, then this is going to be 3 square plus 4 square plus 2 square. So this is minus 3 comma minus 4 comma minus 2. I'll just write it as a matrix, and this becomes square root of 29. Similarly, we can write down TBE. So from B to E, again x is minus 3I, y is minus 4j, 2k cap, and denominator is same. So minus 3 minus 4 plus 2 divided by square root 29. So these are the unit vectors. So with these we can multiply the magnitude of these forces. So TBD goes there and TBE comes here. So now if I look at all the I cap terms here, so I cap is coming from here and coming from. So the x component give us one equation, which is 50 minus 3 TBD minus 3 TBE divided by square root 29 equals to 0. And similarly, if you look at your k cap components, so this one is k cap right here and k cap right here, it gives us minus 2 TBD plus 2 TBE divided by square root 29 equals to 0. So from this equation right here, it's clear that TBD has to be equals to TBE. So with this, if I substitute TBD equals to TBE here, the value of TBD equals to TBE comes out to be 89.75 newtons.